Hey guys, in this video I will be talking about some tips and tricks in Python to help you what we call error-proof your program, and I'm gonna focus on what we call exception handling. So it says right now getting an error or exception, as they call it in Python, in your program means that the entire program will crash. You don't want this to happen in real world programs. Instead, you want the program to detect errors, handle them, and then continue to run. So this is why we call this exception handling, because exception just means an error, and we want to handle the errors so that our program does not crash. Okay, so today I will be showing you some tricks, and I will be focusing on using two keywords in Python called try and except. Okay, so try and except will be helpful in error proofing the program so that we can avoid any errors. So basically what we have to do is think about what will cause the program to crash, what kind of input will cause the program to crash. And then knowing that information can help us kind of get around that input in case the user decides to put that input. Okay, so I'm going to show you two examples, hopefully to kind of get you to understand how this process works. Okay, and these two examples are just examples, and they're just my way of doing certain things. They're just meant to show you how you could use try and except, but obviously there are many different ways, and in coding, um, like I said, there are many different ways to do the same thing. So this is just to help you see what's a few ways to use these keywords. Okay, so let's start by creating a function. So let's create a function. So create a function. You know what? I'm gonna change the theme. I think it's a little too dark. I prefer the lighter theme, I think. Let's see. Okay. Okay, so create a function that takes two parameters that are integers and divides them. Okay, so pretty straightforward function. It's not really that useful because we can just use the slash symbol to divide, but this is just to show you an example of try and except. Okay, so let's create our function. So remember, to write a function we need the keyword def. We're defining our function, and since this is a function that divides two numbers, I'm going to call it divide. Okay, and it needs to take on two parameters. So because it's taking on two pieces of information, we're going to need two variables, and we're going to separate them by a comma. So I'm going to call my first parameter num1 and my second parameter num2. And remember, you need a colon at the end of that. And all this function will do is return the division. So I'm just going to divide num1 divided by num2. Okay, so here's our function. Now, think about, so I want you to think about what would create an error. What would create an error here, right? So here is what I'm thinking. We would get an error if we were trying to divide by 0. So dividing by 0 would give us an error, right? So let's just focus on that. I know there's other situations where we might get errors, but let's focus on dividing by 0. Okay, so before we do anything, let's just set up a way for the user to input these two numbers, num1 and num2. So let's do this. Let's do number1 equals int. So I'm typecasting as an integer, okay, in one shot. Enter a number, and we're going to do the same thing for number 2, so I'm just going to copy and paste that. Enter another number, okay? And now I'm going to print what the program will be doing. I will now divide these two numbers, okay? And so what we're going to do is the following. We're going to call our function divide, and then we're going to save our answer. So answer equals divide. So I'm calling my function divide number 1 comma number 2, right? So I'm calling my function divide on number 1 and number 2. Okay? So, and then I have to print my answer. All right, so we haven't error-proofed anything just yet, but let me just make sure it runs the way it's supposed to run. Okay, so enter a number, 40. Enter another number, let's say 2. I will now divide these two numbers, and I got 20. So 40 divided by 2. I'm going to run it a few more times. Let's say 50 divided by 3. Okay, looks good. Let me see. What else? Maybe one more. So let's say 100 divided by, let's say 2.5. Okay, so I get an error for 2.5 because it's trying, oh, you know what? Let's just typecast as a float because the two numbers might not be integers. So if we're trying to force it to be an integer, it's going to give us an error. So let me try that again. Good thing I tried that. So, oops, sorry. 100 divided by 2.5. Okay, good. So that works. All right. So, I should have typecasted as floats to begin with, but anyway, we got that to run pretty smoothly. Now, remember that we can't be dividing by 0. So let's say our second number, so if our first number is 0, it's no big deal because 0 divided by anything is 0. But if I have 100 divided by 0, now I get an error because what it's trying to do is it's trying to divide by number 2, and in this case number 2 is 0. Okay, so let's take care of the dividing by 0 error. Okay, and what we're going to do is we're going to use try and except. Okay, so what try and except does is with try and except, the program will try to do something, and if while trying to do that thing it gets an error, it doesn't actually crash, it goes to the except part. So maybe we should write that. Try except. Okay. The program will try the try piece, and if it gets an error while executing the try statements, it will not crash, but rather go straight to the except piece. Okay? So let's see what we mean by all of this. Okay, so I'm gonna take this stuff and bring it down because we're gonna still use it, but we're gonna manipulate it using try and except. So here's the syntax for try. It's the keyword try, and then oh, I'm sorry, it's not capitalized. It's lowercase try. Okay. So, and except is also lowercase. Okay. All right, so let's do this. Also, I didn't show you guys that there's actually more situations where we could get errors. So for example, if I run this and the user, you say enter a number and I try to enter G, what's gonna happen is it's gonna cause an error because the computer doesn't know what to do with the letter G. It can't turn that into a float. So what we want to do is we want to make use of our try keyword. So I'm going to say try. So I'm going to tell the computer, try to get input from the user, like number 1 and number 2, right? Okay. And so it's going to try to get 2 numbers from the user. And if it can't, if that causes an error, I'm going to put the result of what I want the computer to do in the except part. So I'm going to print, you did not enter valid numbers. Okay. So I will comment this out for a second just to show you what's going to happen here. Okay, let's see if we got rid of the error of the user entering a letter, for example. Enter a number. Okay, let's say I do 30. Enter another number. Let's say I put G. Look at what happens, guys. It says you did not enter valid numbers. Okay, so this is cool, but now my program has ended, and so it's not that useful because I want to keep asking the user to enter numbers until they enter something correct. So if I want to keep doing something until I get the correct input, I have to use a loop. So what I'm gonna do is tab everything over because this is all gonna go under a loop. So let's do a while true just to get our loop started. And then so while true, it's gonna try to get input from the user, right? Now, if it's able to get number 1 and number 2, then I want to break out of the loop because I've got my 2 numbers, right? But if it was not able to get valid numbers, it's going to say you did not enter valid numbers. And what's going to happen is since it's a loop, it's going to go back to the beginning and ask for number 1 and number 2 again. So this should take care of getting the correct input, meaning we're not going to have letters, right? So let's see. Let's run this. Enter a number. Okay, 60. Enter another number. H. You did not enter valid numbers. Enter a number. Okay, I. You did not enter valid numbers. Enter a number. Okay, 102. Now it's happy and it breaks out of the loop. Okay, good. So here, this is error proofing for letters, for inputs that are not, let's say not integers or floats. Okay, because if I run this, and even if the user doesn't enter a number, but they enter like a space, it says you did not enter valid numbers. So that's perfect, okay, because it's error proofing for, characters as well. Okay, very good. So we just error proofed for inputting an integer or a float, but we still did an error proof for dividing by 0. So actually, it says think about what would create an error here. We actually thought of a different situation where we would get an error, and that's the situation if the user enters a character or letter. So inputs that are characters or letters. And we already took care of this, right? So now we need to take care of dividing by 0. And we're going to use try and except again. And how we're going to do that is going to look like this, right? So we have our 2 numbers. If we get out of this loop, it means that we have our 2 numbers, number 1 and number 2. So what we could do is the following. We could do try, okay, and we're going to try to divide. So we're going to do this. Answer equals divide, number 1, comma number 2, right? We're going to try to do the division. Now, if the division is successful, then I will print the statement, I will now divide, let's say, your 2 numbers, right? Now, you would want to put the statement after you try to divide, because you don't want it to say, I will now divide your 2 numbers and then try to divide, because then it'll say, I will now divide your 2 numbers, but then it won't be able to divide. So you want to try to divide first, and that way, if there's an error here, it skips the print statement and goes to the except part right here, right? Well, we didn't finish the try. So then if it's going to try to divide the two numbers, then we can just print the answer. Okay. Now, for the except part, now if the division doesn't work, that means that we had a 0 in our number 2. So we can print something like, oh, and let's break out. Well, this is not a loop yet, so never mind. So let's print error. You cannot divide by 0. Okay. Let me get rid of this. Let's try this out, the whole thing. Okay? So enter a number, 100 divided by 2. I will now divide your two numbers. I got a 1. Oh, because I have number 2 divided by number 2. There we go. Number 1, comma number 2. Let's try this again. 102. I should get 50. I will now divide your two numbers. I got a 50. Perfect. Okay, let's try something else. Let's try 50 divided by G. You did not enter valid numbers. Okay, so let's try 100. Let's try 0 divided by 100. I will now divide your two numbers. I get 0. Perfect. Let's run again. Okay, let's do 100 and 0. Error, you cannot divide by 0. Perfect. So now this is interesting because if you cannot divide by 0, the program ends, right? Now, you may want to ask the user again to enter again. So what we could do is try to fit this try and except inside of this while true. So let's see, what could we do? Well, we could put a try and except inside this try. Let's try that. So try, and let's take this and put it in here. Oops. Okay. And if that doesn't work, we'll put an except here. And then say print you cannot divide by 0. Put that in here. Okay, let's take a look at this. And then we could break out of the loop over here. Let's see. Oh, I indented too much. Let's move everything back then. Okay. Feel free to rewind, guys. I know I moved through that a little bit quickly, but I'm just trying to show you what we have here. Okay, so this looks like it might work because what's going to happen is it's going to make sure, so this outer try and except makes sure that our inputs are numbers, and this inner try and except makes sure that the second number is not a 0. And it's all inside of a loop, so it should keep asking us to enter whenever we don't have a valid input. So let's try it. Enter a number, let's say G. You did not enter valid numbers. Enter a number. Okay, 50. Enter another number. Let's say G. You did not enter valid numbers. Okay, enter a number. 50 divided by 0. Error, you cannot divide by 0. Enter a number. 30 divided by 3. I will now divide your two numbers. 10. See how beautiful that worked? So we were able to error proof in the same loop for inputs that are not integers or floats, and a second input of 0. So in this loop, using two try and except pairs, right, we error proofed for input that's not an integer or float, and also for an input, a second input that's a 0. Okay, and we did that inside of one big while true loop. And so basically when we have the inputs we need, the correct inputs, meaning both number 1 and number 2 are not characters or letters, and number 2 is not a 0, then it breaks out of the loop. If any of those things happen where we have inputs that are characters or a second input that's a 0, then it's not going to break out of the loop and it's going to keep repeating until we have the correct input. Okay? I hope this makes sense. But this is pretty cool because it shows you how much power you have using try and except to error-proof your program. Okay? All right, very good. I'm gonna comment this out and I'm gonna show you one more example of try and except, just so that when you're doing the longer term projects where you have to error-proof your programs, you have some ideas of how to combine error proofing with while loops and so on. Okay, so for the second program, here's what we'll do. Let's see. Okay, so let's say you're writing a program where a user is ordering stuff from a menu, which you will be doing that later. Okay, so I'm going to help you out a little bit. And let's say you're asking the user, let's say that you charge, let's say this is a fast food restaurant and you charge for the number of ketchup packets. So we're going to ask the user to enter the number of ketchup packets they want and go from there. Okay, so write a program that asks the user how many ketchup packets they want and error proof it. Okay, so obviously you want to do math with these ketchup packets. Maybe you're charging like, I don't know, 10 cents per packet, right? But you want to make sure that the user is entering something valid, right? So think about what would cause errors. Okay, so let's see. Think about what inputs would cause an error. Okay, so the obvious thing is that if user enters letters or characters, right? But then also, let's say the user enters a negative number, right? So if user enters a negative integer, and also if user enters a float, well, a float wouldn't really cause an error. It wouldn't really cause an error, but we don't want a float. We don't want 2.5 packets. So we want to make sure the user is not entering a float. Okay, so let's try this. Let's start with num of packets equals input. How many ketchup packets would you like to order? All right, now we want this to be an integer, so I'm gonna typecast this as an int. But if the user enters 2.5, we're gonna have a problem here. So let me show you. If I run this, how many ketchup packets would you like to order? And I put 2.5, and it's gonna try to typecast this as an integer, and it's gonna give us an error. Now you could technically round 2.5, but then you'll be, if you round up, let's say to 3, now you're doing math with 3 packets, and maybe the user didn't want 3 packets. So you want to make sure that the user is entering an integer, so you don't have to guess how many whole packets they want. Okay, so let's try to get the number of packets let's try to get the number of packets and try to typecast as an integer, right? So what you want to do is put this in a while true loop because you want this to keep asking the user until they enter something valid. Okay, now if this doesn't work, maybe you want to say something like invalid input. Okay, now if we're able to get the number of packets, we can break out of the loop. Okay, so let's try this. Oops, I need to put quotes around this statement. Okay. How many ketchup packets would you like to order? If I put G, invalid input, how many ketchup packets would you like to order? Let's say I try to do 2.5, invalid input. How many ketchup packets would you like to order? Let's say 6. Okay, now I'm good. Now, this is not enough though, because if I run this and I put, how many ketchup packets would you like to order? I put -5. It's not going to give me an error because -5 is in fact an integer, right? So maybe after we get the input, let's say that this line gets executed and it does not cause an error. Well, we need to make sure that our number of packets are not negative, right? So if num of packets is less than 0, then we could print something like invalid input. You cannot order a negative number of packets, right? Okay. So then we will just break in the else piece. So think about what's happening here. If the number of packets is negative or less than 0, it's going to print invalid input. You cannot order a negative number of packets. And then it's never going to break because we didn't put the break in the if part. We put it in the else part. So because the break is in the else part, this is a loop. It's not going to go to the except because I already executed the try, but then it's going to go back to the beginning of the loop and ask for the number of ketchup packets again. So I'll show you how that works. How many ketchup packets would you like to order? Okay, so let's say G, that's not going to work, invalid input. So let's actually make this a more specific error. Invalid input, please enter a number. And here, invalid input, you cannot order a negative number of packets. Please enter a positive number. Okay, let's try that again. Okay, so let's say 6.5. Please enter a whole number, let's say. Okay, so if I put H, invalid input, please enter a whole number. Let's say I put 3.4. Invalid input, please enter a whole number. Okay, so let's say I put -5 now, or -4, let's say. Invalid input, you cannot order a negative number of packets. Please enter a positive number. And then let's say I do 6. Then it exits the program. And just to show you that it works, I'll print you ordered plus str, let's typecast as a string because we're adding it to our statement. You ordered number of packets, let's say ketchup packets. Okay, let's run this again. How many ketchup packets would you like to order? I'm just going to put a bunch of letters. That didn't work. Let's put 5.4. That didn't work. Let's say 6, and then what happens is it breaks out of the loop and it tells me that I ordered 6 ketchup packets. Okay, so very cool. I just showed you guys how to error proof, but not only that, I showed you how to error proof while still asking the user to enter again until they enter something valid. So this is very, very powerful because now your program is not crashing if the user enters something that doesn't make sense. What's happening is you're handling the errors inside your program. That's why this is called exception handling, right? So you predict or you think about the types of things that the user might enter either by accident or, you know, they didn't think about the fact that ketchup packets need to be a whole number, right? So you think about those errors ahead of time, and then you handle those errors inside your program. You're basically, with try and accept, you're telling the computer, try to do this. And if you can't, don't crash, but go to the accept piece of the program where you're printing an error and allowing the user to enter again. Okay? Very, very powerful stuff. I hope that you understood this video. I went a little bit fast, but I recommend that if this is still confusing to you, to go back and rewatch and try these on your own and make sure you understand how they work, because you will be using loops and try and accept in the next two programs we have to do to error proof your whole program. All right?